let's dive in. You got my screen, Paul?
Yeah, looking good. Let's go.
All right. So today we are going to be talking about a really, really common challenge in the world of AI, which is table extraction. We talked to a lot of companies across various industries like finance, banking, life sciences, healthcare, manufacturing companies, and everybody thinks that their tables are the worst. So let's talk about what makes them all challenging in their own unique ways. Some quick introductions on our side. My name is Kevin. I'm on the go-to-market team here at Unstructured. I'm based out of Denver, Colorado. I'm joined by my better half, Paul, who leads our technical documentation for the entire platform. Paul, thank you so much for joining today. What we're going to be discussing is a little bit of background on unstructured, the problem that we solve, why do we think about table extraction. Paul is going to do a deep dive on like simple table structures and complex table structures and what makes them inherently challenging. And then we're going to do a demo of the platform and show off our own table extraction. And then we'll conclude with a Q&A section where you can submit questions. Some housekeeping items on our side. Make sure that chat goes in chat. And if you have a particular question you'd like us to answer, there is a separate tab designated for questions, and we'll try to get to all of those. We will share a recording of this webinar as well as some resources to play around with Unstructured after the call. And then if you have particular use cases you want to discuss with our team, you can go to our website and book a call with an AI expert. All right. So a little bit of background on Unstructured. We were founded 3 years ago looking to answer the question, do companies struggle to take unstructured documents and convert them into a structured output? You flash forward to today, and it's been a really amazing ride. We have 10,000 paying customers, 40 million product downloads for our open source library. Tens of thousands of customers are using unstructured and tons of funding from amazing partners helping us solve this problem. So with that out of the way, Paul, let's talk tables.
Sounds good. Thanks, Kevin. So before we talk about complex tables, let's talk about simple tables. And as you can see on the screen, they're pretty simple. So we really have one and only one header row going across the top in all four of these or five of these examples. I forgot to mark one up, sorry. And then each of these has one or more discrete columns. So in the upper left-hand corner, we see there's a column devoted to the name. There's another column devoted to city, et cetera. Pretty straightforward. I mean, if you've worked with traditional relational database table structures in the past, you're familiar with rows and columns. So there's nothing too exciting here. But let's take a look now at what complex tables are. For example, you can have multiple header rows. So across the top, you can see on the left in this Excel spreadsheet, there are weekdays and groups, and those span multiple columns. And on the right-hand side, you can see that there is a column with multiple rows inside of it. And then you can see in the kind of the upper right-hand corner that there is a header that spans 4 columns. We also have merged cells. So as you can see in all the examples on this screen, a lot of them are simple, and I'm trying to keep them that way, just so we can look at the concepts and not dive too deeply into the data. But you can see in all these examples that we have cells that are merged. They span multiple cells, either on a column or in a header. Multi-level columns. So you can see in the upper left-hand corner here, for example, that we have a subject that has multiple classes.
Sorry, Paul.
That has multiple classes. Those classes have multiple students, and so on and so on.
Next slide.
Yeah. And then we even have some irregular header structures. So what's so irregular about these? Well, on the left-hand side, you can see towards the left of that red box that there's a big blank cell. And some systems could actually get tripped up on blank cells like that. And on the right-hand side, I took a really cute little example to show you. that the critter has a couple of blank cells, and you can see some other blank cells in that red box. So, to us as humans, we look at all these tables and we go, I know exactly what's going on. But when you give this to a machine without a lot of kind of background knowledge, they can get tripped up pretty easy.
So, all right. So, Paul, why are these table structures particularly challenging?
Well, this is a good question because we look at the tables and we don't think they're that challenging. But again, computers without kind of that institutional knowledge or without the context, it can really present problems. As we've seen, there's a lack of a predictable structure. As we went from example to example, and things were kind of all over the place. And so those relationships, while we could probably take a few moments and put our thinking caps on and figure things out, those relationships can be pretty ambiguous. There's really a loss of context and semantics. Like, again, we could probably sit down because we've seen so many tables, could figure it out. Computers are kind of catching up to us. So, one day this will be a lot easier, but right now, a lot of the models still struggle with things like nested complex presentation structures. And again, I showed you some blank cells earlier. If a machine skips those blank cells, it could really mess up the positionality of all the columns and rows. People go, well, we have optical character recognition or OCR. Isn't that good enough? Yeah, I mean, as its name implies, it's good at detecting characters. And some of the more recent OCR models are good at detecting pretty simple tables, as we've shown before. But when we get into complex tables, they really fall down. We'll talk a little bit later about how Unstructured uniquely solves that problem.
Awesome. So, how do we solve it, Paul?
Let's show a picture just to kind of get oriented on how we increase accuracy and provide context. It's a little bit of a busy slide, so let me take just a moment and walk you through it. On the left-hand side, you'll see with the sad face, traditional extraction with many of these other providers will output plain text. So we can see in the little green boxes on the left-hand side that we're trying to go through a table and try to get an answer. And the answer is pretty simple. Based on the table, what's the revenue for 2021? We should get an answer of something like 3815.7. Well, traditional providers will just scrape the plain text. And as you can see, that's not so good because when we ask ChatGPT with that plain text to give us the answer, it messes up in this case. It says it's only 1809. So right now we've lost context, we've lost accuracy, and it actually gives us the wrong answer. On the right-hand side, you can see unstructured, what unstructured does. And again, we ask the same question with the exact same data. But on the right, we actually output the content instead of plain text, we output it as HTML. And the great thing is we really see HTML as providing a lot of context. It tells you which cells are related to other cells, which are the headers, which are the column names, et cetera. And when we ask the question with that from ChatGPT, we get the correct answer, which is 3815.7. Hooray, it says. So you can see in this picture that really HTML is just one of the many things that we'll show you in the demo a bit later that we provide to give you additional accuracy and context.
Awesome. Next slide.
Yeah. So again, there's kind of a wall of text here, but just to briefly summarize, what makes us so good at extracting these complex tables is we'll detect and preserve those table structures. We do it in a number of ways. HTML representation of the table is just one way. We'll show you some other ways in just a moment. We also have what we call enrichments. And enrichment is an add-on that allows summarizations of table contents so that models can get additional quick context without having to read through every part of the table up front. And again, many third-party solutions output only the table's text content, or maybe they'll output a markdown version of the table content, which is better than plain text, but still not necessarily as good as some of the other things we'll show you today. And some other third-party solutions work well only with, like, say, Excel spreadsheets only. And we work with almost 40 different file types including PDFs, Excel spreadsheets, CSV files, etc. So if there's a table inside your slide deck or your document, we're going to detect that just as easily as an Excel spreadsheet. If you want to know how we make sure we have really good quality and we're maintaining high quality at all times and good QA, you can refer to last week's awesome webinar called Rethinking Transformation Quality. I did a really good job of drilling down and showing you how we actually track this stuff, and we can demonstrate that we are improving our quality over time. Of course, be sure to register for next week's webinar as well. Pushing the boundaries of document transformation quality. We'll go into even more detail and show you some more things we're doing to give you a really highly accurate, highly contextual experience for your models, agentic AI, RAG apps, etc.
Awesome. All right. All
All
this is
right,
when I turn it over to you to share your screen and do a
good. So
quick
this
demo.
is what everyone comes for, is the demo. So I think we're doing a pretty good job here, but they want to see a demo. So give the crowd what they want. Anyway,
Exactly.
what I'm showing you here is
Oh, Paul.
unstructured.io. Go ahead.
Oh, are you on the website or were you looking to show the platform?
Oh, I was going to show the website first,
Oh, okay.
um, because I'll show you the user interface. But before I get to that, if you haven't used unstructured before, it's really easy to get started. Just go to unstructured.io, and in the upper right-hand corner, click Try for Free. Just give us a few pieces of information so we can set up your account, and you'll get 1,000 pages a day free for the first 7 days. So you can try us out. Everything I'm doing today, you can try out for free. All right, let's get into it. So this is the user interface. As soon as you sign up for Unstructured, we drop you right into this user interface. It's pretty simple to use. I'll demonstrate it today. In the middle, we have a couple of big squares here. One is the UI Quick Start and one is the API Quick Start. I'm showing you how to use the UI today, but everything you see today can also be driven programmatically with an API. By clicking one of these boxes, you're taken to a quick 2 or 3 minute video and you'll be up and running in no time. So let's go ahead and show you how we create one of these workflows. A workflow is just, I clicked workflow on the sidebar. A workflow is just a series of steps that tells Unstructured what to do. So we're going to click new workflow, and we're going to build a workflow ourselves. And in fact, it builds one for us. You just basically tell it where your documents are, your PDF files, your Excel spreadsheets, etc., how it is to recognize the information, and then what to do with the information. So Auto is a great way to get started if you're not sure how Unstructured works. We're going to customize it just a little bit, though, and we're going to tell it to use high res. High res is basically an OCR-backed recognition of the characters and simple table structures. But for complex tables, we're going to add what we call an enrichment. And the first enrichment we have is a table enrichment. Of course, we're working on tables today, and we have several models to choose from. You can, of course, experiment with these and see which of these models give you the best results for your particular tables. And the first thing we're going to do is provide a table description. This uses a vision language model, a VLM, to basically give information about what it sees the table is all about. It gives basically a description or summary of the table, which is super helpful and provides additional context to your RAG apps or agentic AI. And then we'll also add another table enrichment called table to HTML. As we kind of showed earlier, this is what generates the HTML representation of the tables it finds. Okay, so we've got this all set up. Just took a few mouse clicks, really simple. What are we going to actually process today? Well, I have a file that I grabbed. Let's see, there's the file. No, that's not the file. There's the file. So many
Flattened.
files I play around with and test with. So this particular file I grabbed off of archive.org. It's a highly technical PDF with lots of graphics, etc. And so what you do is basically once you drop that file in here, you click test. Now we're working with a single file today. Of course, you can hook this up to ingest, hundreds, thousands, tens of thousands of documents from your systems of record, but we're just showing you how you can quickly test on a single file, play around with it without disrupting your production environment. And so I'll just scroll real quickly through this. And you can see there's a lot of text with footnotes, there's graphics, there's some fairly simple tables, more graphics. I mean, you can see it's pretty complex stuff, and Unstructured has done a really great job interpreting this. We even see complex equations, etc. It'll take a few moments for this to run. So in true demo fashion, I'm going to flip over and show you the final version. So I picked one of these pages here, page 15, and you'll see there's a number of tables in it. And this middle table right here is the one we want to focus on. We could have picked any of the tables. I just picked this one at random. You'll see it's a complex table for a number of reasons. You can see that this particular header here spans 3 columns here and 3 columns here. And you'll notice in the model column here, we have rows that also span cells. So what do we do when we feed this into unstructured? A couple things are going to happen. First of all, we're going to, that enrichment I showed you, the table description, is going to go through and it's going to read this table and it's going to give us a plain language summary of the table, what it thinks this table represents. I won't read it all for you. You can play with these demos later, but it tries to tell you what all these different acronyms mean, how they're related together. It does some very simple kind of inferences. And again, this is going to be really helpful because not only do you get to learn what a table is, what's in this table, if you're not familiar with it, but the great thing is that you can feed this to a model to give it quick context without having to scan every single row and try to make those inferences on their own. The next thing you'll see is the table is HTML. And again, we've just taken this table. It's pretty straightforward here. We just convert it into a table structure. It has the TRs for the table rows, the THs for the headers, the TDs for the cells. And so again, when you give this information to a model, it's going to be able to say, hey, this particular row is related to this particular column, and these 2 particular cells are related to this particular column, etc. The last thing in here of interest that I won't show you the whole thing, this is about 12,000 characters long. I actually went and counted it because I'm like, how big are these things? You'll just see the first couple thousand characters here. This is a base 64 encoded representation of what we actually found. So why would we need that? Well, for example, you might want to save these images off separately from the document, either in a cataloging system or disaster recovery, or sometimes when you cut and paste tables out of a PDF, you're going to lose some information based on whatever app you're working with. So we give you a full fidelity base 64 encoded version of the image. What can you do with this table as HTML, and what can you do with these base 64s? Well, I'm going to go ahead and flip over to another tab, and I've just basically done a very simple exercise of taking this HTML and saving it to an HTML file. And you can see here that we have, again, full fidelity with things like the cells that have spanned are lined up together. You can see the also the subscripting has been preserved. The bolding of the final row has been preserved, etc. The other thing I'm gonna flip back here, and again, you have this image base 64. What I'm going to show you is I just went up to the web and said, hey, give me a free online base 64 decoder. Obviously, if this is proprietary sensitive information, you don't want to be pasting this into public websites, but just for purposes of demonstration, I've gone to this website and I pasted in the base 64 and said decode, and there you can see this preview image. We have an absolutely full fidelity. I'll flip back over here for you and show you the original. You can see this table. And again, if we go to the base 64 decoder, you can see that we have full fidelity with everything preserved, including subscripting, spanning, bolding, etc. All right, that's the demo. So let's summarize what we saw here. Flip back over to the presentation.
Do you want me to do that, Paul, or do you?
Yeah, could you?
Of
Back to our slide
course.
deck.
It would be my pleasure. Here?
Yeah. Yes, thank you. So what we saw is what we're calling our ETL plus workflow, extract, transform, and load. The plus is all of these great enrichments we showed you today. We used a local PDF file, and we used what's called a high-res partitioner to basically interpret the information in the PDF using an OCR-based strategy. We supplemented that with Vision Language Model, or VLM, model, which gave us table summary descriptions, gave us tables to HTML, and also we gave you a base 64 summary of the images. So let's just flip through quickly. Again, just flip through these slides here. We saw all of the different portions of the output, and want to make sure that we have enough time to get into Q&A. So let's jump into that now. So we have a few minutes left.
Awesome. Okay, so here's a question. Why don't you provide a chatbot template kit for people with no coding skills? Um, so this is like a known issue, and we're always looking to make our product as easy as possible for people with different skill sets. As Paul showed you on the website, you can sign up and you can just drop documents into the playground feature and then connect it to either ChatGPT or other tools, but this is definitely great feedback for our product team. Um, Another question is, does flattening tables make it faster to search for data? My intuition is that it is yes, it will make it faster, but you will lose the structure of the table, which can have downstream issues depending on the use cases that you are supporting. Paul, I have a question for you. OCR tools can usually detect tables to detect text in tables, but they often lose the structure. How does unstructured go beyond OCR to preserve context and meaning in complex tables?
Great question. So as we kind of chatted a little bit about, we use something called a vision language model, or VLM, to really augment what we see in the OCR. Again, OCR is, as its name implies, great for recognizing characters. Tesseract OCR, which is kind of an improvement or kind of an expansion on the original OCR design, is also great for multi-language characters, English, non-English, etc. And it's also great for detecting simple tables. But when we get to complex tables or mixtures of English and non-English characters that aren't supported by Tesseract OCR, and even when we get into edge cases such as handwriting, we really want to use a VLM to do the complex table detection and also outputting as HTML. And so that's what you're going to get with unstructured in addition to traditional OCR.
Awesome. Okay, how do you handle tables spanning 2 pages? A table might start from the middle of page 3 and end in the middle of page 4, or even continue onto the next page. So this is something we hear all the time, which is how do you handle multi-page tables? I can't speak technically on how it works, but I know that it does work because I've seen it. My suggestion for you would be to go online and drop a file that you know has a multi-page table and then inspect the output to determine, hey, like, how good is this? What does it look like? And validate the technology from there. Um,
And I would add just play with some of the different models as well. That's the
yeah,
whole reason why we offer multiple models, because some models are always being tweaked and improved as we learn more and as computers learn more. And so, I would not stop with one model if you don't get the exact results you want. Try a different model and see if that helps you at all.
okay. I want my AI agent to extract the contact details of any person from an Excel or PDF or a reference list with a company name, location, model, supplied, year of supply, etc., and provide the extracted information in response to a query. So this is another really common request. Paul showed you the table extraction and table summary enrichment nodes. We also have a really lightweight MER enrichment node that you can use to define the relationships, define things that are important to you within the documents, and then that node will actually pull that out and append it as metadata to the chunk of information to help with retrieval. Paul, any additional context or thoughts on the enrichment? Uh,
Yeah, I've seen that named entity recognition or NER used with really good success in doing things like detecting product names in the financial industry, stock ticker symbols, et cetera. Even people and organizations, it'll detect those, and then it'll also try to infer the relationships between all those. Again, when we see a stock ticker symbol, we know it's a stock ticker symbol, but some systems might not, have been trained on that. And so you can say, hey, this is a stock ticker symbol. It's just one simple example of the power that NER brings to the solution.
And a little teaser, in a couple of weeks, we're going to kind of showcase another piece of functionality that we're rolling out, which is the enrichment node is a really lightweight tool. We're launching a structured data extractor using the VLM, which we are really excited to showcase. So stay tuned for that. Okay. What other questions? Okay, we have some coming in real time that I can't see. How can we access the links from the deck? Um, Paul, which links are in the deck? I don't totally know which links they're referring to.
There were two links to our events, our webinars.
Okay.
Um, and if you want to, you just go up to unstructured.io, look under resources, webinars, and events, and you'll get right to those if you don't have the deck handy.
Okay. We will be sharing the deck in the follow-up email with the recording of this
Yep.
webinar. There's
Yep.
a question about we would use the models in Bedrock. Yes, we do support Bedrock models as well as Vertex models inside of our platform. These are kind of rapid fire. Paul, how do we make sure that we have the table info part of the same chunk? I don't know if you can interpret
Yeah.
the question on the fly, but
Yeah. I mean, look at our chunking documentation for more details. But yeah, you can preserve tables with chunks, and then we use metadata to help you find out which elements are related to other elements. So good.
awesome. I just realized that we are at time, and I can't see the chat, so I didn't realize I was getting blown up to wrap things up. But I just wanted to say thank you so much for everyone who joined. Really appreciate the thoughtful questions, and we will be here next week, same time to do another webinar. So thank you all so much.